Hello everyone, welcome to our presentation. Today we're going to explore the fascinating world of whole numbers. This is the first slide, so I want to start by introducing the topic with enthusiasm. The title of our presentation is Whole Numbers, and we'll also look at some key concepts related to them. Over the course of this presentation, we'll cover what whole numbers are, how they work, and why they are important. I'm excited to get started, so let's dive in. Now, let's take a look at the contents of today's lesson. We'll start with the number line, which is a visual tool that helps us understand the position of numbers and their order. Next, we'll explore some important facts about whole numbers, which are the foundation of our number system. Following that, we'll define what exactly whole numbers are, so you have a clear understanding of this concept. Then, we'll discuss the predecessor, which is the number that comes just before a given number. Lastly, we'll look at the successor, which is the number that comes immediately after a given number. These concepts are essential because they help us understand how numbers relate to each other and how we can move through the number system efficiently. Throughout this lesson, keep in mind that understanding these basics will make learning more complex math concepts much easier in the future. Let's take a closer look at the definition of whole numbers. The numbers we refer to as whole numbers are 0, 1, 2, 3, 4, 5, and so on. These are the numbers that include 0 and all the natural numbers. In other words, whole numbers consist of 0 plus the natural numbers, which are the counting numbers starting from 1. Understanding this distinction is important because it helps us see how whole numbers form the foundation for many other number systems we will explore later. So, when we talk about whole numbers, remember that they include 0 along with all the positive counting numbers. Let's talk about some facts of whole numbers. First, the smallest whole number is 0. This is a key point because it sets the foundation for understanding how whole numbers start. Next, it's important to realize that there are infinitely many whole numbers. No matter how high you count, there's always another whole number just beyond it. This concept of infinity is quite fascinating and really highlights the endless nature of whole numbers. These facts connect to the overall theme of understanding the basics of numbers and how they form the building blocks of mathematics. Now let's talk about the concept of a successor. Essentially, when we add 1 to any natural number, the result is called the successor of that number. It's a way to move to the very next number in the sequence. For example, if we take 12 and add 1, we get 13. That means 13 is the successor of 12. This idea is fundamental because it helps us understand the natural order of numbers and how we can build counting step by step. It also ties into the overall theme of understanding the building blocks of mathematics, starting from simple concepts like adding 1 to find the next number. Now let's talk about what we call the predecessor of a number. Essentially, if you take any natural number and subtract 1 from it, the result is the predecessor of that number. For example, if we look at 12 and subtract 1, we get 11. So in this case, 11 is the predecessor of 12. This concept helps us understand how numbers are related to each other in a sequence. Recognizing the predecessor is fundamental when working with numbers, especially in counting or understanding sequences, because it shows us the step just before a given number. This idea ties into the overall theme of understanding the relationships between numbers, which is key in many areas of mathematics.